Hello and welcome to a video lesson on reflection and rotational symmetry. So reflection symmetry is going to be basically flipping a shape and it's going to go back onto itself, so kind of fold. And then rotational symmetry is we're going to turn it and it's going to look the exact same, aka rotate onto itself. So let's talk about reflection first. So a line of symmetry is a line that divides a figure into two identical parts. So think about the middle of something. The shape of an object is symmetrical if both sides are the same when a line is drawn through the middle of it. So I want you guys to look at the following quadrilaterals. We have A, B, C, and D, and I want you to sort them into categories based on their lines of symmetry. So for example, maybe the shape has one line of symmetry, maybe it has more than one, maybe it doesn't have any at all. So I want you to sort them into groups based on their lines of symmetry. Okay? So press pause and sort away. So here's what I got. So the following shapes do not have any lines of symmetry, A and C. And I bet you picked A, but C is pretty tricky. And so here's why. So C is a parallelogram. I have my parallelogram. If I fold it, it's not going to be the same on both sides. So if I fold it, I guess, hot dog style, we can see that this is not matching up exactly. Okay? You can also fold it horizontally and also see that it's not matching up exactly. So I've got some space over here. Okay? So even though it looks like if you fold it, it'll be symmetrical, it's not. So that's tricky. Shape B, Shape D had one line of symmetry straight down the middle, so trapezoid had one, and then a rectangle is going to have two lines of symmetry, okay? So you can't fold it at the diagonals for a rectangle, you can only go vertically and horizontally, okay? All right, so hopefully you can identify lines of symmetry. So two-dimensional figures have reflection symmetry if you can draw a line through the figure so that one portion of the figure is a mirror image of the other. So our shapes would be B and D. They have reflection symmetry because I am allowed to draw a line through the middle. Okay, A and C would not have reflectional symmetry. All right, let me know if you have any questions on reflection symmetry because we're going to move to rotation symmetry. So rotation symmetry is when a shape coincides with itself. Coincides just means goes back to itself, looks the same. Okay, so when a shape coincides with itself after a rotation less than 360 about its center, that is rotational symmetry. So if I turn something and it looks the exact same, fewer than 360, then it has rotational symmetry. The reason it has to be fewer than 360 is if I turn it 360, it's back to what it was. So, of course, everything, if you turn it all the way around, will have the same. So, the number of times a shape returns to its original position during the 360 rotation is called the order of rotation. I should probably highlight that. Order of rotation. The relationship between the angle of rotation and the order of rotation is illustrated by the following formula. So, here is our formula. Okay. So to find the degree, you're going to take 360 and divide it by n, where n is the number of sides of a regular polygon. So a triangle that has all the same size and shape, a square that has all the same size and shape, a pentagon. So a regular n-gon basically is something that has all the same sides, lengths, same size, same shape. So let's take a look at an example. So I have a pentagon down here. Okay, it's a regular pentagon because all the angles are the same and all the sides are the same. So to find the degree of rotation, you're going to say 360 because that's what it takes to turn all the way around. Whoop, divided by the number of sides. So pentagon has 1, 2, 3, 4, 5 sides. So I'm going to say 360 divided by 5, and that'll give me one turn. Whoops, and it's going to be 72 degrees because they give it to us below. Okay, so if I rotate an object 72 degrees, which is kind of hard to visualize, that pentagon will look the exact same. So they kind of did a picture down here to show it. If I put a dot on the top and then I rotated it 72 degrees, that dot would now be in this corner, but the pentagon still looks the exact same. You wouldn't know I turned it unless there was that dot there. Okay. To find the other degrees of rotation, I'm just going to do 72 and 72. So you can either multiply by 2 or you can add 72 and 72 together. Okay, and so if I rotate it twice, that's going to be 144 degrees. And I'm writing terrible on this. Okay. Okay, so then if I go 3 turns, 72, 72, 72, you can either add 72 3 times or multiply it by 3. And I think it's 216, but I'm not remembering, so I'm going to type it in. I was right, 216. Okay, I'm going to add 72 to that again, or do 72 times 4. Let's move my face. And get 288. Wow, it is really hard to write. Okay, and then if I go 72, 72, 72, 72, blah, 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 I get back to 360. Okay. All right. So these are the degrees of rotation that will rotate the object onto itself. Okay. 360, we kind of know, of course, it's going to rotate it all the way back to itself. All right. So that is how you find rotational symmetry. 360 divided by number of sides, and that is it. Okay. So I'm going to show you a cool thing real quick. So this shape is a square, okay? So if I wanted to do my formula, I would say, hey, 360, and I would divide it by the number of sides, which is 4. 360 divided by 4 is 90, okay? So if I take this shape and move it 1 turn, let's watch it, turn, 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 90. So it lined up perfectly. If I want to turn it again, turn, 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 turn. That would be 90 and 90, which is 180. And then if I want to turn it one more time, turn, 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 turn. That would be 90 and 90, 90, 270. And then if I want to start all the way back with the original, 360. Okay? So that's just another example of how to find rotational symmetry, and I hope that visually helps you see it. All right, so now you're going to try the rest of this packet on your own. There's some notes problems. I think it's 3 or 4 problems, and then we'll come back and talk about it. So finish the rest on your own, and then we'll go over it. So we have a square. For number 3, I wanted you to draw all the lines of symmetry. So here's one diagonal, horizontal, and the other diagonal. So that would be 4 lines of symmetry. So that would be the answer to number 5. And then it wants to know the rotational symmetry, including the identity. So the identity one is the 361, okay, because that turns out all the way onto its own. So 360 divided by 4 is 90. And so 90, 180, 270, 360, we kind of talked about that. Okay, so again, identity symmetry is the 361. All right, we also have another pentagon over here, and you can draw 5 lines of symmetry. So you start at the vertex of a letter, so 1, 2, 3, 4, and these are terrible lines, 5. So there's 5 lines of symmetry, because it's a 5-sided figure. To find the rotational symmetry, you would do 360 divided by 5, and we kind of get the same numbers that we started with. And again, the identity symmetry is 360. Okay? Moving on. This one was a little tricky. It's got a flower within a circle. So basically the most important thing is that flower. So there are 6 rotational symmetries because there are 6 like flower petals. Okay, so 1, 2, 3, 4, 5, 6. So I can turn that 6 times and it looked the same. The reflections was kind of tricky. So the book says it's 12. I can see how it's 6. So for example, if I draw one line of symmetry, there's 1. I can draw another one, there's 2, and then 3, and then 4, and then 5, and then 6. So then I kind of have them all, but then the book's like saying, okay, keep going around the circle to get the other 6. So you can draw 12 lines, but 6 of them overlap. So tricky. Go with either one. C wanted you to only make it have 3 rotational symmetries instead of the original 6. And to do that, you just have to shade in 3 things, because then that makes that shape unique. So you could have shaded this flower petal, the other flower petal, etc. Okay, so if I turn that, then I'll have a rotational symmetry. I can turn it, have a rotational symmetry. Or if you didn't want to do the flower petals, you could have colored the outside of the circle and turned that, etc. Okay, that was a little tricky, but a good extension problem. Last but not least, kind of like a puzzle. So these are only some answers. It wanted you to shade 2 of the 9 squares so that the following is true. So on A it said you want 1 vertical and 1 horizontal line of symmetry. So if I shade these 2 middle, I have a horizontal line of symmetry, same on top and bottom, and I have a vertical line of symmetry, same on left and right. B said 2 lines of symmetry about the diagonals. So you basically had to shade the corners. So here is 1 line of symmetry, same top and bottom. Here's another line of symmetry, same as the top, same as the bottom. Okay. Again, you could have had many answers to this. This is just one example. C said 1 horizontal line of symmetry. So you had to shade something on the top and match it to something on the bottom. D was 1 line of symmetry about a diagonal. And so here is one example. I only have 1 line of symmetry, and it's only the diagonal. And then no lines of symmetry would be this example. So I can't draw any line that would make them symmetrical. Okay? So that was kind of like a little fun puzzle, hopefully. Get your brain thinking. All right, so let's wrap it up. Check for understanding. So describe reflection symmetry. So reflection symmetry is when you reflecting over a line of symmetry and it's mapped onto itself. So basically I can fold it over and it is the exact same shape. Okay. Rotational symmetry is when you rotate it between 0 and 360 and it is mapped onto itself. So again, symmetry is when it is mapped onto itself. And then rotational symmetry, it's got to be bigger than a 0, but then less than 360. So any numbers between that. And then the identity symmetry is the 360 one. It's the one rigid motion that is going to map it onto itself. Okay, so rotating anything 360 will automatically make it itself. Okay, all right. Thanks for watching and learning reflection symmetry and rotational symmetry. You can now practice.